All right, so here's what the rest of the calendar year is going to look like. We have 2 weeks left really of new material, and then 1 week that's going to be taken up with like final exam review and final exams. So 3 weeks of school, and then we get 2 weeks off. And then it's January when we come back. So here's what's going to happen. For the next 2 weeks, we are going to continue with 4.1, and we're going to get into 4.2. It's going to be exponential and what we call logistic. Okay. And that's going to be the last of the new material. Now we have 2 tests already in the book. We need 1 more test this 9 weeks, but we're not going to sit down and test specifically over exponential and logistics. So what's going to happen then is at the very beginning of that 3rd week, maybe even the Friday before, I'm going to make a final exam review. And we do this every year. This is like my Christmas gift to y'all, just so that you know going in. The final exam review I make with the computer program that's pretty ancient, okay? But it's actually pretty cool because what it's going to do is it's going to generate, I don't know how many, either 25 to 33 multiple choice questions. I don't know how many we're going to have. If there's 25 of them, they're going to be 4 points apiece. Essentially, if there's 33 of them, they're 3 points apiece. So more questions, they get diluted. But I'm going to give you class time to work on that. Maybe even at the end of the 2nd week there, because that last week, I'm not sure what the schedule is yet. But you'll have a couple of class days to work on that in class, and I will give you the key, okay? So you're going to have the answers to that. And by answers, I mean like number 1 is going to be answer choice A. Number 2 is answer choice B. I'm not going to show you how it's worked out, but you'll know if you're getting the right answer, okay? Then what we're going to do for the 3rd test, your 3rd test is going to be, this by the way, is going to be Form A. Let me just go ahead and say that. This will be Form A. Your 3rd test is going to be the final exam review, but it's going to be Form B. And we'll take that in class, okay? So preparing for the final exam is also going to prepare you for your 3rd test. Now, here's the difference between Form A and Form B. This computer program, it's not new. It's not very, very robust. So the difference is going to be the questions are all going to be in a different order. It's going to jumble the order of the questions, and it's going to jumble the answer choices, okay? And every once in a while, it even changes a number or 2, but not always. So like on the review, if it's 5 to the x power, then on Form B, it might be 3 to the x power. That's it. In other words, you'll recognize the equation. You'll recognize the equation. And that'll be your 3rd test, okay? And then your final exam is going to be, guess what? Form C. Okay, now a couple of notes. These are all going to be no calculator. No calculator. We just tested over the calculator. So I'm not going to put a question on any of these that require the calculator. Okay, no calculator. And the content is going to be anything from the year so far. Going all the way back to the beginning, simplifying expressions, exponents, all that stuff. But it's going to be heavy on the new material, which is going to be exponential and logistics, okay? Because we're not going to be testing specifically over the new material, your final review will be heavy on the new material. But this is your gift. If you go through that final exam review, for which you're going to have class time and be able to work together and have the answers to know if you're doing them right, then you should walk out of here on those last 2 assessments with 100 on both of them. Because again, you're going to almost be freaking out when you get Form B. You're going to be like, that's Mr. Corpy, come over here. Yeah, what's the problem? This looks almost identical to Form A. And I'm like, I know, you're welcome. And then same thing on Form C. It's going to look almost identical to both the other forms. You might even be able to recognize what the answer is without even doing the work because it's so similar to the other ones. Does that make sense? Yeah, it's still math, but it's a gift. If you do the work, you should end up with a really nice score on both those final assessments. Okay. So we got 2 weeks to get through, a little bit less than 2 weeks to get through all of the exponential stuff that I want to get to. And then when we come back from, the holiday break, a 2-week break, it'll be January. It'll be 2022. Oh, what's 2022 going to hold in store? Well, it's going to hold in store probably new variants, right? We're on Omicron right now. But Omicron is not as deadly as the Delta, supposedly. But we're in Omicron, so we might be up to like Zeta by the end of next year. But we're also going to be doing logs next semester. Yeah, logs, right? Oh, logs. And then we're going to roll into trigonometry, which is really the second semester of Precal. So anyway, should be a lot of fun, right? COVID aside, the math part should be fun. All right. And we won't be using Omicron, by the way, next semester. We'll be using theta. So theta is a Greek variable, not unlike Delta and Omicron, but we use it to represent an angle. So wouldn't that be kind of coincidental if when we're studying angles and we're using theta, we're on the theta variant of COVID? That would be kind of like something, wouldn't it? That'd be something to write back home about. Dear mom and dad, the funniest thing happened today. We were in the middle of trigonometry and Dr. Fauci came on TV and said, and then you're like, why am I writing a letter to you when I'll see you this afternoon? But that's not true if you're Maria or Paula. But do you even write letters? You email, right? Or you like Snapchat or FaceTime, right? Or if you're an Android dude like I, you have to Google Duo, right? Right. But I'm okay with Google Duoing. It works. It works for me. I'm a holdout. All right. Any questions on what the rest of the academic year will be? Yes, sir. They sent me an email and I'll, yeah. Thank you. It's just me, not, yeah. When you come in tomorrow, I will have the semester final maybe into Canvas so that if you don't have it, you can have it. And I'll have that board over there written out. I moved the bookshelf so that I can have that board full of quotes and what's its and rebus puzzles and mad gabs and cool stuff. And I didn't do that today. I'm sorry. Okay. But I just showed up this morning trying to say, whew, how can I make up for 9 days of no productivity? But they call it break for a reason, right? Thanksgiving break. Any other questions or comments or puns or good clean jokes? Okay. Well, here we go. We're gonna talk quickly today about what this diagram means. The values of our exponential functions vary, from one equation to the other. If we look at a function that's exponential, that's in this form: y equals b to the x, where the y-intercept is what? What's our a value here? If it's not there, it's implied to be 1, right? These are those special cases. These are like your default parent functions when your y-intercept is 1. If the base is greater than 1, we have what? Exponential growth, okay? These are going to be exponential growth functions. Oh, and just to review, it was 9 days ago. We know it's exponential again because we have a variable in the exponent and a numeric base, all right? So our exponential growth functions on this picture are going to be right there. I'm going to highlight them all in yellow. Now, what do they all have in common? Okay. Besides the fact that they are, written in Times New Roman with black font. Well, they all have y-intercepts, as we just said, of 0, 1. And they all have horizontal asymptotes at y equals 0. Okay. So if you drew that horizontal asymptote down here, notice that the end behaviors of these exponential functions are dramatically different. And that's one of the very striking features of exponential functions that'll carry forward into your advanced studies, like of calculus. They have very different end behaviors. On the left side, for the growth functions, they go to 0. But on the right side, they go to infinity, right? Very different. So they're only affected by the horizontal asymptote on the left-hand side. Now, here's what we want to know. We want to fill in the blanks here, okay? For growth functions, for growth functions, comma, the blanker the base, comma, the steeper the graph. The blanker the base, the steeper the graph. Well, let's take a look. The least steep of our exponential growth functions that are shown is 2 to the x, right? In this case, when I say steepness, I'm not talking about slope. Let's make the quick distinction. In math class, slope is a vector, right? You have a negative slope, which decays, falls from left to right, and you have positive slope. You can have a positive slope that's very flat, that is still bigger than a very, very steep negative slope. Okay, so when I talk about steepness, I'm talking about in any direction. 3 to the x is steeper than 2 to the x, right? 5 to the x is steeper than 3 to the x, 10 to the x is steeper than 5. So what goes in the blank here? Bigger, right? Bigger would be a good word. The bigger the base, or the larger the base, right? The bigger the base, the steeper the graph. Yeah, that makes sense. Okay, 2 to the first is 2, 10 to the first is 10, it's bigger. Now, that means two things. As you go out to the right, not only does it go to infinity faster, but look what happens when they cross paths at 0, 1. 10 to the x not only goes to infinity faster, but it also goes to 0 faster, right? So it is steeper. It goes to 0 faster than it goes to the top. All right, now on the other side, if the base is between 0 and 1, I'm just going to call these the unhighlighted ones. Okay. If the base is between 0 and 1, then we have decay. All right. And now we're going to say they have the same features, by the way, right? They still have y-intercepts of 0, 1. And they still have a horizontal asymptote at y equals 0. But notice now that it's switched. Now the left end behavior for the decay is infinity and the right end behavior is 0. Let's fill in the blank over here. You can actually just copy this. Don't have to write it again. Just copy it, paste it over here, and just get rid of the words in the blank. And I guess for growth, we have to change that. So for decay, the blanker the base, the steeper the graph. Well, which one's steepest? We have 1/2, 1/3, 1/5, 1/10. Smaller, very good. 1/10 is the smallest. And so it's kind of the opposite, right? The smaller the base, the steeper the graph. And that kind of makes sense if you think about what those two graphs, 10 to the x and 1/10 to the x, how they're related to each other, or 5 to the x and 1/5 to the x, how they're related to each other. Do they have any kind of symmetry here? Y-axis symmetry, very good, okay? Let's just say b to the x and 1 over b to the x, their counterparts are symmetric to each other. Across the y-axis, okay? So 10 to the x goes to infinity on the right-hand side at the exact same rate 1/10 goes to infinity on the left-hand side. They are mirror images of each other across the line y equals x. Now here, it's easy to prove. Let me show you how to prove that. We're going to be doing trig proofs later in the year. To prove something, you want to start with something that has more information rather than less information, because it's easier to tear things down than it is to build them up, right? So if I look at 1 over b to the x to start with, that's the same as, well, 1 over b, that's the same as b to the negative first. And now when I raise a power to a power, I can multiply and I get b to the negative x. And if you think about standard transformation form, if I take the exponential growth function b to the x and multiply the x by a negative, that's a y-axis reflection. Anytime you do that with any function. So remember, a negative out in front of the whole thing is an x-axis reflection. Your y values are changing. But when you have a negative in front of your x values are interchanging. Positive x and negative x change sides, and that happens across the y-axis. So that's a real easy algebraic proof, okay? Now, we're going to have to pledge here very, very shortly. Starting tomorrow, we're going to pick up with example 5, and we're going to meet a brand new parent function. We're going to meet E, the number, not E, the vowel. And for the rest of your mathematical career, E is going to be the most important, probably the most important transcendental number or irrational number that you're ever going to work with. More so than pi, more so than the square root of 2. Okay? All right, comments or questions? All right. Enjoy the rest of your day.